Welcome back, class. Today we are on lesson 2, Powers and Exponents. So go ahead and get out your book. Make sure you are on page 15. That's where we're going to be starting today. And once again, at any point with this video, if you don't understand something, feel free to just hit pause and go back a little bit and re-watch an example or a section or whatever you need to do. Now that you're on page 15, let's go ahead and get started with the real world link. This one has to do with savings. It says, Yogi decided to start saving money by putting a penny in his piggy bank, then doubling the amount he saves each week. Once again, the key there when reading this is that he is doubling the amount each week. Use the questions below to find out how much money Yogi will save in 8 weeks. Complete the table below, find the amount Yogi saved each week and the total amount in his piggy bank. Okay. Now here we have something kind of strange. It's starting at week 0 at 1 cent, 1 penny. So that's just kind of to take up. It's not. He puts money in that first week, but it's not a full, complete week. You know, if you put money in on Monday, you haven't completed a full week. So it's just kind of a different way to look at it. So at week 0, he has 1 cent for a total of 1 cent. Then on week 1 here, he puts another penny in after he finishes the first week, and he now has 2 cents. Now, keep in mind, he didn't just add a penny here. That's not what's happening. It's not a +1 situation. He is actually doubling, multiplying by 2. It just so happens that 1 times 2 is 2, when also 1 plus 1 is 2. And then he now has a total of the 1 penny the first week, 2 pennies the second week, for a total of 3. So we're going to fill out this table. This 2 here, we're not going to put a 3. That's a +1. That's not what we're doing. That's not a power or exponent. Power and exponents have to do with multiplying. So we are actually multiplying right here times 2, just like we did right here. So 2 times 2 is 4. So we put a 4 right there. Now, how much money does he have? Well, he put in 4 right here. He already had his 3 for a total of 7. So basically, this is just continually multiplying by 2. 4 times 2 is 8. You add your 8 to your previous amount right there. 8 plus 7, 15. Then we take 8 times 2. So multiply by 2 again. 8 times 2, 16. Then we're adding 16 and 15 together right there. So we get a total of 31. Multiply by 2 again. 16 times 2, we have 32. Then we add those together. He put in 32 pennies that week, plus the 31 pennies he already had in. He now has 63 pennies. Then we multiply again by 2. So this next week he puts in 64 cents. We add that 64 with that 63. We get a total of 127 right there. How many 2's are multiplied to find his savings in week 4? So right here, his total savings in week 4, how many 2's do we actually end up multiplying? Well, we have 1, 2, 3, 4 2's multiplied for week 4. What about week 5? Well, for week 5, it was just another multiply by 2. So we have 5. How much money will Yogi save in week 8? Well, that's where we need to kind of go down here and finish part of the table. So as we look at that, it says how much money will he have in week 8? Continue the table and you find out if he will have enough to buy a pair of shoes for $80. Okay? So here we have week 7, where he has $1.27, so which is 127 pennies. Here it says 128.
Yeah, but this is 127 for week 6. You double 64 to get 128. His total savings is 2 pennies.
Yeah, I was going for that total there, certainly. Okay.
It's all good.
All right, so here we have, once again, the 64 cents were given in week 7. or week 6. So to find for week 7, we double that, which gets us basically 128 pennies, which is essentially $1.28. Moved along here, I'm going to just start doubling all of this, and you can kind of just keep doing times 2 in your calculator. This is one way to fill out the table if you want. I'm just going to keep doubling all these. So we have the 1024 times 2 will give us 2048. We do that times 2, and we get 4096. Now you notice on that week 12 there, look at how much he's putting into his piggy bank by doubling. We started way over here at a penny, we kept doubling, and we ended up way over here. So how much money will Yogi save? Week 8, we look at week 8 here, how much is he going to contribute to his savings? Our answer, we discover, is right there. Now the question is, on 4 here, continue on the table, will he have enough money to buy a pair of shoes for $80? So we look here at week 12. I multiplied all by 2, but I didn't add everything up. So I'm going to start adding this to that one, just like I did above. He has a total of $5.11. Then we add that, and we get a total of $10.23. We add the next, we get $20.47. Add the next, we get $40.95. Add the next, and we get $81.91. Now in this scenario here, it asks, could he buy a pair of shoes for $80? We have a total of $81.91. So our answer would be yes. But state when after 12 weeks. Okay? So that's kind of how powers and exponents work. It's always a multiplication process where you keep multiplying. In this case, it was multiplying 2's together. Sometimes it's different numbers. So turn the page, and we're going to take a look at some of those. Here it says a product is represented. A product of repeated factors can be expressed as a power. That's one of your vocab words. Power that is using an exponent and a base. Okay. So if we look here. This has 4 factors. That's the number of times something is repeated. So that translates into 2, which is the base. That's the big number being multiplied by the exponent, which is the smaller number up top. And that number represents how many times it's being multiplied together. So it's being multiplied together 4 times. So our exponent's 4, but the number being multiplied is 2, so our base remains 2. That's the difference between a power, a base, and an exponent. A lot of people get those 3 words mixed up, so make sure you can identify that the base, the exponent, and then the power. All right? Now, read and write your powers. So 3 to the first power just means there's 1 3. 3 to the second power means there's the 3 taken twice. So we have 2 3s. That does not mean 3 times 2. Do not say 3 to the second power is 3 times 2, and that's 6. It is 3 being multiplied by another 3 2 times. 3 to the third power is a 3 being multiplied 3 times, 3 3 3. 3 to the fourth power is 4 3s, all being multiplied together, and so on. Then every now and then you'll see to the nth power. That means 3 to the power of n, or 3 to the nth power. It just means you have this almost like a repeating type scenario where n is just some number that we haven't determined yet. Okay? So example 1. It says write each expression using exponents. So here we have -2 times -2 times -2. So look here, what's our base? Our base is our -2. How many times is -2 being multiplied together? 3 times. So that's where we get right here in our answer, -2 3 times to the third power. But there's this other part here. We have a base of 3 being multiplied together. How many times? 4 times. So that's where we get 3 to the fourth power. All right, let's go ahead and move on to example 2 now, where we have A times B times B times A times B. It says use the properties of operation to rewrite and group like bases together. The base A is a factor 2 times, and the base B is a factor 3 times. So we're basically going to create exponents, powers, exponents here, except we're just using letters instead of numbers. But the same basic principles apply. Before, we were looking at how many times numbers repeated, and then we would raise something to that power. This time we're just using letters instead. So we're looking at how many times certain letters repeat in order to create something. So let's take a look here. We have A 1, 2 times. So we have 2 A's, which gives us an A times another A, going from right here. Now, just like above, where we had the -2, -2, -2 3 times, and that means that we then had an exponent of 3. Here we have an A, but we only have it 2 times, so that means we have A to the second power. Then we look at our B's, 1, 2, 3. We keep those as our bases right there on the bottom. Then the exponent that goes with those is a 3. All right. Another example of this that I'm going to do out to the side right here would be to take something like this. We'll maybe take x's, for example. We'll take, actually I'll work right over here to the side. We'll take an x times x times y times x times x times a y. Why not? So we look there. What are our different bases that we see? Basically just 2 things, x and a y. Now I'm going to add one more. I'm going to throw in a z. So we have x, y, z right there. So we have how many x's? 1, 2, 3, 4. And they're all being multiplied here. So my base is still x. How many of them do I have? 4. So the exponent that goes with it is a 4. Times, I look at my next letter or variable. That's a y. So I know I have at least a base of a y, but how many do I have? I look at it, I have 1, I have 2, so I have an exponent with it that says y to the second power. Then finally, I have my z. Now there's a couple ways you can do this. You can just keep it as a z, or I can look here and go, okay, how many z's do I have? Well, I only have one of them, so you could put it with an exponent of 1, or just leave it as a z. Typically, since there's only one of them, we would just leave it as a z, but either way would technically be correct. All right, for the next couple examples, Miss Neely is going to go ahead and take over.
All right, guys, let's move on to page 17. And we're on example 3, and it says evaluate. Anytime you see the word evaluate, that means to solve. So we want to solve this problem. It says I'm taking a -2/3 to the 4th power. That means I'm taking a -2/3 times a -2/3 times a -2/3 times a -2/3. I'm taking the 2's times each other 4 times, and I'm taking the 3's times each other 4 times. So now let's look at D. D says 4 to the 4th power. So I know the numbers that I'm multiplying together is a 4, because that's what the base tells me. And the exponent, the small number, tells me how many 4's I'm going to multiply together. I'm going to multiply 4 of them together. So I end up with 4 times 4 times 4 times 4. And if you take a 4 times 4 times 4 times 4, you end up with a 256. So the answer to D is 256. Now let's look at E. It has a -2, and I'm taking it times itself 6 times. So that means I have 6 -2's. And I'm taking each of them times each other. So a -2 times a -2 is a +4. A +4 times a -2 is a -8. A -8 times a -2, a negative times a negative gives me a +16. A +16 times a -2, a positive times a negative gives me a -32. And a negative 32 times a negative 2, because I have negative times a negative, that gives me a positive 64. So my answer is a positive 64. Go ahead and do F for yourself. You're probably going to see that again on either a bell ringer or a quiz. All right, let's look at number 4. Example 4. It says a deck of a skateboard has an area of 2 to the 5th times 7 square inches. What that means is that they're going to take 2 times 2 5 times and then multiply that whole thing times 7. Well, 2 to the 5th power, 5 2's multiplied together gives you 32. And 32 times 7 is 224. So let's look at G. It says a basketball court has an area of 2 to the 3rd power times 3 times 5 to the 2nd power times 7. Whew, that's a long one. Okay? So let's start off by multiplying it. Well, when I end up with 2 times 2 times 2, well, 2 times 2 is 4, and 4 times 2 is 8. So I have 8, I've taken care of those, times 3. 5 times 5 is 25, times 7. So I have 8 times 3 times 25 times 7. And if you put that into your calculator, you will end up with 4,200 square feet. Okay? Now let's look at number 5. Number 5 tells you a value for your two variables. Remember, a variable is what we use in place of an unknown value. And we can't solve it unless we know what those variables are. So, or what those variables equal. So let's look at this example. This says that I have a squared, and if I look up here, it tells me that a equals 3. So that's the same as having 3 squared plus b squared, and if you look at the top, b is 5, or I'm sorry, b to the 4th. So I have 5 to the 4th. So I have 3 times 3, which is 9. And I have 5 times 5 times 5 times 5, 4 5s, which gives me 625. And when you add those together, you get 634. Now let's look at example 6. It's the same thing, only this time the exponent is on both the a and the b, and they're inside parentheses and it's squared. Well, my a I know is a 3 because that was what my problem told me, was that a equals 3. So that a becomes a 3. That b becomes a 5 because that's what the problem told me, was that b equals 5. And 3 minus 5 is a negative 2. So it's saying that that negative 2 is then squared. So a negative 2 times a negative 2 equals a positive 4. Let's do another one over here and see if we can't come up with an answer to it. Let's say that I want to do a cubed plus b squared. Remember, a is 3, b is 5, so I have 3 cubed plus 5 squared. So I have 3 times 3 times 3 plus 5 times 5. I have 3 3's, and I have 2 5's. 3 times 3 is 9. 9 times 3 is 27. 5 times 5 is 25. So then I end up with a 27 plus 25, which is a 52. Okay? Let's see if there's another example. All right. Go ahead and work on H, I, and J. See if you can't get an answer for them, and you'll probably see them again. Have a great night, guys. Bye.